Sorry about that, my Apple Pencil ran out of battery. So for numbers, we're going to factor out a 4. Now let's think about the a's. We have a to the third, a squared, and a to the third. So there is an a in every term. We're going to factor out the smallest power, which in this case is a squared. Next, looking at the b's, we have b squared, b to the third, and b to the third. There is a b in every term, and we're going to factor out the smallest power, which is b squared. So to figure out what's left, we divide every term by what we're factoring out. In this case, we're dividing every term by 4a squared b squared. Eight divided by 4 is 2. A to the third divided by a squared, we subtract the exponents and get a to the first, which is just a. B squared divided by b squared, they cancel out. And then we have plus. 16 divided by 4 is 4. A squared divided by a squared, they cancel out. B to the third divided by b squared, we subtract the exponents, 3 minus 2, and we get b to the first, which is just b. Then we have plus. 20 divided by 4 is 5. A to the third divided by a squared is a to the first. B to the third divided by b squared is b to the first. When you're factoring out a greatest common factor, you should always be able to look at what's left, and there shouldn't be anything that all of those terms are divisible by. If there is something that they're all divisible by, that means that you should have factored out something different to begin with. You factored out a common factor, but not the greatest common factor. If we look at this one, the first two terms are divisible by 2, but the last one's not. The last two terms are divisible by b, but the first one's not. So there's nothing that all of these three terms are divisible by, which means we did factor out the greatest common factor. All right, let's try another example. Here we have 12x to the fifth minus 24x to the fourth minus 6x to the third. This is a kind of expression you'll run into a lot when you're trying to solve equations later on in this chapter. So here, thinking of the numbers 12, 24, and 6, we want to think of what all of those are divisible by. It would be 6. Next, looking at the variables, x to the fifth, x to the fourth, and x to the third. There's an x in every term. We factor out the smallest power of the variable, which is x to the third. So to see what's left, whoops, that should be a 3. We're going to divide each of these terms by our greatest common factor that we're factoring out, 6x to the third. So on the first term, 12 divided by 6 is 2. X to the fifth divided by x to the third is x squared. Then we have a minus. 24 divided by 6 is 4. X to the fourth divided by x to the third is x to the first, which is just x. Then we have a minus. A lot of students make a mistake on this last one. Whenever the top and bottom of a fraction are exactly the same and everything cancels out, it's not 0. Think of, for example, 5 over 5. It would be 1. 6 over 6 would be 1. 20 over 20 would be 1. Whenever the top and bottom of a fraction are exactly the same and everything cancels out, it's a value of 1. So this would be our final answer in that case. Let's take a look at another one here. Here we have 8x to the fourth minus 12x squared plus 5. So looking at our numbers, we've got 8, 12, and 5. There's nothing that all three of those are divisible by, though. So there's not a number we can factor out. Next, looking at the variables, we have x to the fourth on the first term, x squared on the last term, or on the middle term. The last term, there is no variable. So there's no variable that's in every term. So here, the greatest common factor would just be 1, and there's no point in factoring out a 1. So here, you can just put that we can't factor out a GCF here. at that. You would leave it alone. Sometimes you can factor things, sometimes you can't. And this is one of the cases where you can't.